Okay, in this video I'm just going to run through getting some oxidation states for some different elements in compound. So, sulfur dioxide, SO2. Here I'm not going to be doing Lewis structures, all these things. I'm just going to use some of the standard rules to explain what the oxidation state would be here. So I have two oxygens. Oxygen is one of the ones whose oxidation state I can predict. So I have my sulfur plus two oxygens. They'll be 2 minus each. And this is a neutral compound, so it has to add to 0. So sulfur's oxidation state minus 4 equals 0. So in this case, sulfur would be plus 4. Potassium nitrate, KNO3. K is going to be plus 1. Oxygen, again predictable, at minus 2. There's 3 of them. And again, this is written as a neutral compound, so it all must add to 0. So, plus 1, plus whatever nitrogen is, plus 3 times the negative 2 oxygens, has to add to 0. So, plus 1 plus n minus 6 equals 0. Collecting like terms, plus minus 6 and plus 1, I get minus 5 equals 0. And here, nitrogen's oxidation state is 5. Positive 5. Magnesium phosphate. So, magnesium is an earth alkali metal, so that'd be plus 2. The oxygens would be all minus 2. And there's 4 of them in compound with the whole thing where there's going to be 2. So, again, this is written as a neutral compound. So I have 3 magnesiums at plus 2 each. I have, all in brackets, 2 times this because I have 2 phosphates. Phosphate plus 4 oxygens. And that all has to total to 0. So 6 plus 2 phosphate minus 4 times 2 times 2, that'll total to 16, will equal 0. Collecting my like terms, 2 phosphates minus 16 plus 6 is minus 10. And so my phosphate, in this case, will work out to be plus 5. So I can use my simple rules to get most compounds without bothering with the Lewis structure. 2 more here. Let's just give ourselves a little more space. There we go. Anyway, okay. Lead 4 carbonate. Lead, carbonate. And this would have been 4, and this would have been 2 minus, so when I cross them over, I would have gotten 4 and 2, and that would have reduced to 1 to 2. So that's what this compound looks like. This is lead 4, so its oxidation state is plus 4. Carbonate, there are 2 of them. Carbon's the tricky one near the staircase that we don't know. Oxygen is standard at minus 2. And because, again, this is written as a neutral compound, this would be adding to 0. So plus 4, plus 2 carbons, minus 6 times 2 is, minus 12. There we go. Has to add to 0, see 2, and then that 6 is minus 12. So 2C, adding like terms here, minus 12 plus 4 will be minus 8. And so carbon will work out to be plus 4 here. Sulfuric acid, H2SO4. H, I don't think I mentioned in the previous video, but H is always plus 1. Actually, H can be plus or minus 1, depending on what it's bonding with, but typically here it's with a polyatomic, so it's going to have donated that electron to the polyatomic, so it would be plus 1. The vast majority of times with hydrogen it's plus 1. It can only be minus 1 if it happens to be in a compound with something with a lower electronegativity, something like, say, lithium hydride or something like that. Something like lithium hydride. Anyway, here it's with a polyatomic, so it's going to be plus 1. So 2 times the plus 1. Sulfur is the guy that we don't know. We have 4 oxygens at minus 2 each, and a total of 0. So 2 plus whatever that sulfur is, that's an S, not a 5. Minus 8 equals 0, so sulfur, in this case, would be minus 6. It occurred to me when I made up these examples that I didn't just do a straight polyatomic so we could see something that doesn't add up to 0 but adds up to some charge. So let's do ammonium here. Ammonium has 4 hydrogens at plus 1 each. And the nitrogen, that's the one we don't know. But here, because this isn't an uncharged molecule, but instead is just the ion part, we don't add to 0, we add to plus 1. So nitrogen, we add to whatever that charge is. Plus 4, plus 1. So nitrogen works out to be minus 3 in this case. Let's do one more of those. Let's take sulfate, SO4 2 minus. Here, we are going to add to negative 2 because we have a negative 2 charge on our ion. We have oxygens at negative 2 each, and our sulfur. So sulfur minus 8 is going to be equal to negative 2, and sulfur, in this case, is plus 6. So that's how we can use our simple rules from the previous video to do oxidation states of things by looking at the total oxidation state of the molecule. Remember our rules. Elements have an oxidation state of 0. Oxygen, this isn't always the case, but in almost all cases it's minus 2. Halogens, minus 1. Metals, alkali, plus 1. Earth alkali, plus 2. Multivalent is whatever their valence is. Trying to think if there's any other ones in there. Oh, and hydrogen. I nearly forgot him again. And he is almost always plus 1, but can be minus 1 when in compound with metals. So that video shows you how to get the oxidation states of elements in compounds. Next, I'm going to look at some more complex compounds, like some organic compounds, to see in those cases how we have to use the Lewis structure to come up with the oxidation states of the atoms within them.